Okie dokes. We're gonna use a Kraken X44 to power a gear, which is gonna turn a wheel, with the belt and pulley. It is 1:40 a.m. I have to be at school at 8 o'clock tomorrow, and I still have homework, so might have to split this into 2 videos. But we're gonna start by sketching on the front plane. So the first thing we have to do is make our motor mounting. So I'll link this somewhere, but we're using a Kraken X44, so you can find that on WCP and then click its PDF. But the outer diameter is going to be 1.732, so let's start off with that. Actually, let's start off with the mounting holes. So 1.375. I don't think there's really a good way to explain like exactly what I'm making here, but this is basically the radius that the circle that all the small bolt holes will be along. And also I've been using Onshape for the FTC videos, so I haven't used SolidWorks in a while. Okay, and I believe that there are 12 holes. Okay. Well, on the X60s, there's 12 holes, so I'm assuming it's like the same. Or 11 holes, but we'll just draw on 12. So this is the bolt hole. This is going to be 0.196. And that is like a number 9 drill bit, I think. No, number 7 drill bit. And we're going to make a circular sketch pattern of the screen recording thing. How do I? There we go. Circular sketch. My screen recording software is like right here, so I can't actually click there. Parameters, I think that means center. And the entities to pattern are going to be these bolt holes. We want 12 of them. So there are actually 11, but this one's just missing, but it's spaced out as if they're 12, so we'll just put in 12. And this is also good because you can rotate the motor. So when you're assembling it, they can put it in whatever orientation they want. Okay, that looks right. And notice it's all blue. Blue means underdefined. So what you can do is you can just drag the center and it won't actually move. It'll just define it. No. Yeah, there we go. Next up, we'll do the center one. So there's like a little part of the motor that's going to protrude. So we need to make a hole for that. That one is 0.75. There's no reason to have like tight tolerance on this. And sometimes if you're putting a pulley on, you actually need it like way bigger. So 0.75 will make it like 0.785, I guess. So it should be totally fine. Actually, we can go even more. We'll go 0.8. So this should mount fine. This is all we need to mount our motor. We can draw on the outer diameter, although it is like weirdly shaped. I've never used X44s before, but we're gonna start using them. I ordered like 8 for this season, so future years we'll have a lot. And the things that are construction basically just mean they're not going to be a part of our plate. They're just there to help us get the geometry right. This is 1.732. I'm copying all these values from a PDF sketch of the motor, which if I'm posting to the YouTube video, it'll be linked below, or just go to WCP website. Alright, now we're going to do some gear meshing. This is another like part of CADing for FRC. You need to know how gears mesh. So you're going to have their pitch diameter, which like, I mean, you can probably Google it and figure it out if you care enough, or you can ask me in person, I'll explain it. But a pitch diameter is basically like where the gears touch, in theory. So we're going to go with, we're going to use an 8-tooth pinion, which is 0.5 pitch diameter. And the bigger the differences between your gears, the more torque it's going to generate. So it's based on the gear ratio. Actually, I'm gonna do a whole separate video explaining gear ratios. So just copy this for now. And then we're gonna attach this to a bigger second gear. I'm probably rambling on about a bunch of stuff I don't need to, but I'm actually really tired. This is gonna be, we'll call this like we'll do a 64 tooth gear. So you can use 64 over 20, it's gonna give you the pitch diameter for this. That's because we use 20 DP gears in first, or an FRC. I guess FTC probably uses like 10 DP. And that the DP basically just kind of like dictates the type of tooth. And then it'll affect like the relationship between the amount of teeth versus your size of the gear. And so in theory, the pitch diameters are tangent, but we do want to leave a little bit of space because it won't, there'll be like extra friction if there isn't a little bit of space. Okay, and we're gonna make the little bit of space gonna be 0.002. That's 2/1000 of an inch, so it shouldn't affect it too much. And then we're gonna make these horizontal. I select multiple things by shift clicking. And then in this center, we're going to need a bearing. So we're gonna put this. Bearings are 1.125 plus tolerance, 1.127. Standard tolerance for us is 2 thou. If we're outsourcing machining to like Peninsula or something, it might be a little bit different. But if we're machining it in-house, it's gonna be 2 thou for basically everything. And the next thing we're gonna do is we're gonna attach this to a pulley. So we need a pulley on this axle as well. Let's see, I think I memorized all the pitch diameters. So we'll start off with a small pulley, 15 tooth, I believe is 0.94 pitch diameter. And then we'll go and put a bigger pulley with the big wheel down here. I guess I'll just like put it on the side. Okay, we'll start with the wheel. We'll make the wheel like 4 inches because that's a pretty standard flywheel size. But obviously the flywheel will not be a part of the plate, so it's going to be a construction circle. And I'm actually going to move it like slightly down because like there's never really a case where when these are such similar sizes that you would have the wheel here, because the game piece would likely touch the gear. But I mean, I guess it's just an example, it doesn't really matter. But we'll move it down so you can see some different types of dimensioning. So we can do the vertical dimension here. I'll just make this 1 inch for now. And then we can set the horizontal distance. And you'll notice that I'm kind of setting arbitrary values here, but what you would do is set the value that you want it to be roughly, and then it's going to have to change to make sure it's the proper belt length. We'll say it's like 4.25. And then we're going to need to put a pulley in the center of this. So pulleys work the same way as gears. They increase the as you change the reduction, the torque will increase, which, I mean, again, it's going to go in a different video. So we're going to put a pulley in here, and it's going to be a 36 tooth, which I believe has a pitch diameter of 2.256, maybe. You have to check WCP for this, but I'm just like kind of remembering things. Because I spent a lot of time staring at WCP PDFs. Okay, and then we need to put in the bearing on this one. So it's probably best to use an equals constraint. Equals is always good because it takes out like all the random number junk. You don't want to have a bunch of random dimensions. Like if we had dimension each one of these circles, it'd be super cluttered. But saying that, you should also know like when things might occasionally be different don't make them equal, because then you're going to like struggle to change things later. But obviously bearing holes will never change. These holes will never change because they're bolt holes. And like for other motor mounting, I could also use the same. I could set it equal to this outer diameter. But then if you made like a pinion, you wouldn't want to set it equal because you might want to change the type of pinion you have. Okay, and next we need to do belt length. So belt length is probably, it's something I recently found out Poly Robotics didn't really care about for a while, but you definitely should. So what we're going to do is we're going to take the two pitch diameters of our pulleys, which is this one and this one, and we are going to make two tangent lines, and they're both going to be for construction. So we're going to do one on the top, and if you like click and like drag out, it'll make a tangent, and then if you hold it here, it'll become tangent on the other side. So those are our two tangent lines, and then we're going to use a path dimension, but first you have to trim off what you don't want included in the path. So we can use this trim entities tool and take off this part, there we go, and here. So this path is basically just representing our belt. And so if we click this drop down, we can do a path length dimension, and we'll select all the parts of our path. And we'll make this dimension driving. It's going to break some things, but that's why I said we need to make sure that we're willing to change this a little bit. So we can either delete this one or we can delete the 1 inch one. I would say the 1 inch is more important than the distance from the motor and stuff. So we'll delete this and it should fix everything. And now we want to change this path length. So I have a second computer here, so I'm going to figure out what 13.85 inches to millimeters is. 351. It's 352. So we're going to find a belt length. Belt lengths are in millimeters, that's why I did the conversion. So we're going to find one that's like close to it, so probably a 350 millimeter belt, which is a 70-tooth belt, 350 millimeters. So we can set this to 350 millimeters. And so you can see happened here is just like more or less the closest point that we could get our wheel to be relative to the motors with the real belt length. If we wanted to be even more accurate, you could play around with the size of each pulley, but this is increasing the most torque, so I'm just going to leave it like that. Also, this is just an example, it doesn't really matter. Yes, is that it? Okay, so this is basically all the geometry we need. Now we have to make the actual plate. So we're gonna, let's see. I like making things tangent to like the end of whatever is getting mounted to it. So I'm gonna make the outer diameter on this the same size as the outer diameter of the motor, which is gonna be 1.732. And then we also need to make standoff somewhere. I guess this is something you could do. You could put a standoff right in the center here. So a lot of times you're just gonna have to make some like random geometry things. Actually, do I want to do this? No. We're gonna put standoffs here. Here, like out here. Okay. So all these standoffs are going to be 3/8 of an inch because they are 3/8 round stock, which you guys have probably all milled before. And we can set them all equal. So again, this is the time you can set them all equal because 3/8 round stock will never change. Standoffs are basically all 3/8 round stocks, although I'm thinking about like printing more and more of them for this coming season. But yeah, for now we can say they're all 3/8 round stock, and inside them they're gonna have a number 7 drilled bore, which is 1032. If they need to be like really strong, we might use quarter 20. But because they're 1032, we can just set them all equal to these bolt holes. If you wanted to change them, they'd become 0.201 for a quarter 20. This is 0.196, that'll be fine. And then always define everything. So, okay, I guess we are going to use some random dimension here, or some random construction stuff. We can do this, and then we can do this. And then I'm going to make these two lines perpendicular. And let's see, where is the midpoint on this line? Does that look like it'll work? Yeah, we can do that. Okay. So we'll find the midpoint here. If you just kind of hover over it, it'll show you where it is, and we can coincident make that with this. Okay. And then I want the standoffs to be like as close as possible without touching the wheels or the belt. We have to account for the belt thickness too. So I'm going to leave this, I think we can leave this, that is not what I meant to do. Let's get rid of that. Nope, get rid of that. Okay. I'm going to make this like 0.25. This is kind of all up to you, just like make sure it looks roughly right. Okay, it needs to be more than that. The reason why it needs to be more than this is because it's very close to the belt here. This is the pitch diameter of the belt, which means there's a little bit of extra thickness. So it probably would be fine, but I'm going to make it 0.375. That should definitely be good. Yeah, that's plenty. And then this one, I guess we'll dimension this to the belt. I'll just make sure this is like 0.25 for the belt. Okay, that looks good. And then this one, I'm going to set it horizontal to here. There's no belt to worry about on this part. So I'm just going to set it 1/8 from the edge of the wheel. That's not 1/8. Okay. And then the last things we need to do. So I guess we should do this because it's good practice. Yeah, it's a good thing to do. To offset all of your bearing holes just to ensure that you don't like accidentally make a plate too thin. I do 0.25. Peninsula, I know, is doing 1/8 on some of their gearboxes, and we are generally not like aggressive enough for their pocketing. So maybe soon we'll switch. But for now, I've been doing 1/4 inch. I did that last season, so we're gonna keep it. And basically this just means that we don't want the plate to be thinner than this near the bearing holes, because it'll just be really thin here and it might break. And even 1/4 inch plates do like just snap sometimes. That happened a lot in Crescendo for us. So we want plates to be strong. And then the last thing to do is just make like the outer part of our plate. So we're just going to connect everything with lines. I'm going to connect it from the motor part to the standoff. Because it's not touching this, it doesn't really matter. That's why I said we didn't really need this circle. And I'm going to do this one. I guess we didn't need that circle. Well, we do. To this one. And we'll go here to here. Nope. Yeah, sometimes the tangent tool is like kind of bad. Yeah, like that. But if it doesn't work like that, you can just manually make a tangent by selecting both of them. Alright, yep. You can also see, like, if it's really close, like they're almost a straight line touching this point, you can tell, like, they'll intersect. And if they do intersect these two lines, then you don't need to touch like the middle point. but they don't intersect here, so we do need to use the middle entity. Okay, let's go here. Alright, that looks good. Is this our plate? I don't think there's anything we're missing here. If there is, it's 2 a.m. and I want to go to sleep, so I'm not going to do anything about it. Okay, next up, we need to make these sides. Oh, I guess we should definitely put a standoff here somewhere. So you can put standoffs on mounting holes for motors, because we can just like put a standoff on it and have the bolt go all the way through and thread into the motor. But if it's like a really long plate, you would never do this because there won't be a bolt long enough. But if it's less than like 2 inches, it's probably fine. So this is, no, let's not dimension it, let's set it equal. So let's get rid of this dimension and set it equal to the standoffs. Okay. And then I guess I'm just gonna make this, it's like kind of annoying me. So I'll just make this tangent, oh, there we go. And, alright, that looks good. And then let's trim off this part, because this is not needed. This part can also get trimmed. Alright, never mind, let's just leave it because it's breaking things. It's a little bit annoying because we're going to have to extrude all of these little points. Let's see if I trim this, will it work? If I trim this one too. Did it fix everything? Okay. Oh, okay, everything's good now. Yes, are we okay? Are we okay? I hope everything's okay. Okay, now we need to know like how far everything needs to get extruded. Generally, you want to keep them as thin as possible, but like also it sometimes doesn't matter. So we're going to, yeah, okay, I think we're gonna do like 2 wheels here with a pulley in between. It's kind of weird, but that's fine. So let's exit this sketch. Now we're gonna make a perpendicular sketch. So on the right plane. Okay. So we're gonna start off with the 1/4 inch plate. Nope. Let's go to the corners. 1/4 inch plate. The heights on these don't really matter, just the widths. So close 1/4 inch plate. And then we're gonna put, what did I say? Where you need to like, you want small spacers. You don't really want, you don't want wheels touching your plates because that's gonna cause extra friction. Some wheels might come with slight like spacers or like flanges on them, in which case you don't need this. But we're gonna add a small spacer. Like, oh my god, why does it keep going here? Okay. We're gonna say it's like a 1/8 spacer. And then we're gonna go with the 4 inch wheel. Then we need the pulleys, which are 9mm belts. They're 0.563, I think. If you're wrong, okay, 0.563 width. And then we need another 1 inch wheel. I haven't dimensioned any of these, by the way. I'll do that at the end. And then we're gonna need a spacer here, 1/8. So this is like the part for the wheel, and then we need the last 1/4 inch plate. So I'll go ahead and dimension all this right now. What is often good to do is to make a center line here and then reflect it all over. But I forgot, so it's fine. Also, this isn't like that much. Sometimes you're gonna have a lot more things. And also you can't make as many changes if you reflect it. So maybe it's fine. Okay, so this is 0.563, I think. You should probably look at this in WCP. I'm just going off like what I memorized. Oh my god. Why are none of these like together? Okay, let's make these collinear. I guess the heights don't really matter, so realistically I should have just made them all the same heights that they like automatically get mated. Like start them from the same point. But like it's fine. It's just gonna work. Okay. What the heck is happening? Oh my god. Okay, this is fine. There we go. There we go. Okay, that looks right. Yeah, okay, what I was saying there is like, after we made this first rectangle, we should just make everything off the corner. Oh my god, I hate SolidWorks. Okay, just make everything off the corner like this. Because then they'll all move with each other, but whatever, it's too late. Okay, and then this one we said is 1/8. And this one is 1 inch. 1 inch is just the thickness of the wheel. And then we said these two are equal, blah, blah, blah. We said those two are equal. Okay, and then I'm gonna set like these distances, which you do not need. This is like 0.75, which I think is about the diameter of a spacer. This one is 4 inches. Okay, that's fine. Okay, actually, we are going to make all the heights the same. Okay, this is really dumb. I did this really dumb. Don't do it like me. Just when you're sketching them, just make them all start from the same corner. Okay. I totally could cut stuff out of this video, but I'm definitely not going to because I'm pretty lazy. So these are 2 plates, so we'll make these. Nope, one more collinear. Okay, and then these 2 are both spacers, so make those collinear. This one, this is going to be the diameter, which on this one was like, what, 2.256? And then these 2 are collinear. Okay. So this is like the part where our wheels are going to go. We have 2 wheels. We have the pulley in between. And pulleys have flanges built in, which is why I'm not putting, it's not a flange. It's like slightly thicker than the big part of it. You'll see when I do the assembly next time. But you don't need spacers on the edges of pulleys. Or gears, because gears also have like little spacers built in. Okay, and then on the top, we're going to do a what am I thinking of? Gear. We need a gear that's going to be 1/2 inch thick. Gears are 0.498, so we'll just call them 0.5. Because that kind of has like built-in tolerance. And then I forgot what size we used. I think we used a 64 tooth. So we'll call this 64/20. Is that all? Oh, we need the flanges on the edges of the, So, now these are the little flanges on the edges of the bearings. They are 1/16. So we'll go put those in. And then are we done? I hope we're done. then okay, also I feel like I mentioned this before, but all these heights like don't matter. But they are kind of helpful so that you know where you're like what you're doing, like what each one represents. Just like for example, if I make this 1.127, like I know this is meant to be a bearing. So yeah, I think that's it. And sometimes like if you really know what you're making, and like during build season I was really tired, I wouldn't put in all this junk. I just kind of like know the distance I wanted between them. I would just add it on the side. But that's like the lazy way of doing it. You should really, this is probably a better way of doing it. And basically what this is going to do is it's going to let us sketch, it's going to let us extrude this sketch, like from this vertex to this vertex, and then from this vertex to this vertex. So we have 2 1/4-inch plates. And by doing that, if we want to add a third wheel, we can just like change this sketch. And we're just sticking everything. So it would change all of our parts with like 1 dimension change here. Okay, we're done. I have to go do my homework. It's 2 a.m.